Okay, this video is about the derivative of the inverse of a function. So so you recall, this goes back to algebra. Let's say you had the function y equals x plus 6. That's the original function. And you want the inverse. The inverse is when you switch the x's and y's. So you would just switch your x for y's, and then you solve for y. This is called the inverse function. So if this is the original function f of x, we would write the inverse function as f inverse of x. So it's the little to the negative 1 means inverse. You've also seen, I think, on the mock exam, it was referred to as arc sine. Well, arc sine x would be f inverse of sine x. So you don't usually see the arc part with just a regular inverse one. It doesn't have to do with trig, but I'm just bringing that up. Okay. So, but here's the problem. What if you had, so let's say that you needed to find the derivative of the inverse. So if this is the original and it asks for the derivative of the inverse, you could easily find the inverse, which is this, and then the derivative, y prime, would just equal 1. But it's usually not that easy. So what if you had something like this? If I switch my x's and y's, I get this. But now there's no way for me to put this in the form y equals, so therefore I can't do what I just did. Okay, so you're going to copy this down. The derivative of the inverse of a function, this is a rule you should have written down, at a point is the reciprocal of the derivative of the function at the corresponding point. Okay, so you can pause and copy that. I'm going to move on and do an example. So here's an example. If f of x equals x squared, find a derivative of f inverse x at x equals 9. Okay, so this is a problem that you could do as like I did on the first one, but we're going to do it 2 different ways so you can see how they both work. So if I have y equals x squared, and I switch my x and y, and I take the square root, I get y equals radical x, which is the same thing as x to the 1/2. I can easily find the derivative of that. And now I know that y prime is just 1 over 2 radical x. And x is 9, so I can put 9 in here. And I get 2 times 3, which is just going to give me 1/6 as my answer. Okay, so that's if you can get it into the form y equals. You're not going to be able to do that, but I'm just doing, like for the real problems they're going to give you. But I just wanted to use this as an example so you can see how the rule works and how you'll get the same answer. Okay, so I'm going to take this out. So we should get an answer of 1/6. That's what we're looking for. Okay, so we said the derivative of the inverse of a function. So the derivative, oops, trying to erase this, and it doesn't want to erase. Sorry. Okay, I got it back. All right, so the derivative of the inverse, right, so that would be the inverse of x, the derivative of it, is going to equal the reciprocal of the derivative. So the reciprocal is going to be 1 over the derivative of the function of the corresponding point. So it's going to be f prime of f inverse x. Sorry, I'm having trouble with my stylus. Okay, so this is really your official rule right here. What we wrote before, this is it in notation. Okay, so if you want the inverse of a function, the derivative of the inverse of a function, it's going to be 1 over, you're going to do the derivative of what is that inverse. Okay, so we're going to do it for this problem and you'll see what I mean. Alright, so we're starting off with y equals x squared. Okay, so remember, it's saying here at x equals 9. But if we're talking about the inverse, remember you switch the x and the y's. So in this case, if we want to talk about the inverse, we're going to say put 9 in for the y instead of for the x, because the x's and y switch. So what does x have to be? So when you square it, you're going to get 9. X would have to equal 3. So you're going to take that 3 and you're going to put it in over here, because that's the corresponding point. Okay, so we have 1 over f prime of 3. Okay, so this f inverse x is this 3. Okay, now we need f prime of 3. Okay, so what is f prime? Well, here's f. F prime is equal to 2x, and f prime of 3 will just be 2 times 3, which will get you 6. So this is going to equal 1 over 6, which is what we got doing it the other way before. Okay, we're going to do another one. Okay, here's a new example. So for this one, we need to find the derivative of the inverse of 3x cubed minus x plus 7 at y equals 9, not at x equals something this time. So we're going to use our formula. As soon as I see derivative of the inverse, I'm going to write my formula. So it's going to be the derivative of the inverse is going to be 1 over f prime of f inverse x. Okay, so y equals 9, so we're going to put 9 in over here. So 9 equals 3x cubed minus x plus 7. Now typically these types of problems, all you have to do is like do guess and check, and it's usually either 1 or 2 is the answer. So what would the value of x be in order to make this equal 9? Well, if x equals 1. Right, so if x equals 1, you're going to have 3 minus 1, which is 2. 2 plus 7 is 9. So what we're looking for is 1 over f prime of 1. Okay, so what is f prime? Here's our f right here. So do it down here. F prime is going to be 9x squared minus 1. So we want to know what is that when you put 1 in there. So you're going to get f prime of 1, which is going to be just 9 minus 1, which is 8. So you're going to get 1 over 8, and that was the answer. Okay, so there's two different ways that you're going to see this. Either, we'll go back, you're going to be given an x, and then you need to switch it, put that in for the y to find out what the real x is that you want, or you're going to get it like this, and you're going to be given the y, and you just need to solve for the x. Okay, we're going to try another one. Okay, this is another example. Sometimes you're given a table, and notice this table is all about f. But they're going to tell you that g is the inverse of f, and you should find g prime of 6. Okay, so what we're going to do is, we're definitely interested in 6. So you're going to look over where is y equal to 6. Okay, so why am I choosing y? Because it's the inverse. So that's why I'm not thinking of this as an x, it's because it's the inverse function, so we're thinking of y being 6. So when is y equal to 6? Right here. And you can see that x equals 2 when y equals 6. So we have a point 2, 6. Okay, so what is f prime of 2? Well, f prime of 2 is right here. and that's equal to 1/3. But remember, we don't have g prime of anything, right? That's what we're looking for, g prime. So why don't we look at f of 2? F prime of 2, sorry. So f prime of 2 is equal to 1/3. Well, what's the reciprocal of 1/3? It would be 3. The reciprocal equals 3. And that's actually the answer. G prime of 6 equals 3. So what we're doing is we're first finding the derivative of, so when we're doing the 1 over the f inverse, I'm sorry, the f prime of the f inverse. So this piece over here, that actually became our 2 over here. So we ended up with 1 over f prime of 2. Well, f prime of 2 equals 1/3, but you're going to have 1 over 1/3. So that would give you the 3. Those are pretty tricky, but the good news is that usually you just have to find like the matching kind of number and to see what goes with that, and then maybe do a reciprocal. All right, I'm going to do another example. I know these are confusing. Okay, here's another one. We're given y. G is the inverse of y, and we need g prime of 0. So we're going to go to our formula. So we're going to do 1 over f prime of f inverse x. And it's going to give us 1 over f prime of something. Okay, so what is the something? So this looks like it's an x, but remember we're switching them because it's the inverse. So we're saying that that's the y. So we're saying y equals 0. So you're going to plug that in over here. So you're going to get 0 equals x cubed plus x minus 2. And now you need to find a number for x to make this true. And the only thing that's going to work is if x equals 1. Right, because we get 1 plus 1 is 2, 2 minus 2 is 0. So we're going to take this 1 and we're going to put it in here. So we're looking for f prime of 1. Okay, here's our f. So f prime is 3x squared plus 1. Y prime of 1 is going to be 3 plus 1, which equals 4. So this becomes 1 over 4. And that was the answer. And I have one more for you. Okay, so here is our problem. And g is the inverse of this y function, and we want g prime of 13. Okay, so remember, we're not thinking of it as x equals 13. We're thinking of y equals 13 because it's an inverse function. So we're going to put 13 in here for y. And then you have to figure out what is x to make this true, and x would have to equal 1. I had told you it's always either 1 or 2. Okay, so we're doing 1 over f prime of f inverse, which we now know is 1, right? So we need 1 over f prime of 1. So we need to find the derivative of that. So the derivative is 15x to the 4th plus 18x squared, and we're interested in when this is equal to 1, and we're going to get 33. And so the answer is 1 over 33. Okay, and that's that. Oops, I just wanted to mention one more thing. Sometimes you'll see something that looks like this. They'll say f of g of x equals something, and g of f of x equals something, and those somethings are the same. That means that f and g are inverses of each other. So if you see that kind of notation, that means that f and g are inverses. Because sometimes they'll just give you that information, and then they'll ask you all these crazy kind of questions, and you have to recognize that we're talking about inverse here. Okay, and now that's finally it.